Welcome everyone to the Northwest EcoBuilding Guild and Hempitecture's new webinar, Carbon Negative and Non-Toxic Hemp Building Materials. A lot of us have been thinking about this and working on this for many years, so hoping that hemp building materials would become a thing of the going concern in our building and construction trades. But of course, it's been illegal for many years. We've been fighting for it, and now it's finally come time that it's able to be used for building materials in the United States. We're going to have a great panel of two speakers today who have been pioneering in this field for quite some time. But before we get to that, I just wanted to, take a moment to let you guys know what you can expect during the event today. And I'm going to be jumping back and forth a little bit here to make sure that everybody gets in the meeting. We've got about 12 folks in the waiting room. Here they come. So for folks who are still joining, we're just getting started. Today, during our agenda, we're just going to take some time to welcome everyone and ask you to introduce yourself using the chat box, just your name, organization, and why you decided to come to our webinar today. And then we're going to ask a couple of questions here, find out what people's role is in the industry, et cetera. And then the main body of this webinar today is going to be showing 4 videos that Mattie, Mead, and Hempitecture put together explaining all this, and so that'll be a pre-recorded section of the agenda. Then we'll have one more question at the end, and about 20 minutes for Q&A at the end of our 2-hour webinar. So with that, I want to just take another moment to introduce myself. My name, again, is Chris Van Dalen. I am the chair of the South Sound chapter of the Northwest EcoBuilding Guild, based in Olympia, Washington. We cover the kind of Olympia and the Tacoma areas of this region, but the Northwest EcoBuilding Guild is a 3-state regional organization made up of architects, builders, contractors, suppliers, and homeowners. Anybody who's really interested in transforming the built environment for long-term sustainability. The Guild was founded in 1993, so we're 27 years old this year, and has done a lot of groundbreaking work in the Pacific Northwest to advance a 200-year perspective on the built environment. We do a lot of education programs. We have a website called the Building Innovations Database, buildinginnovations.org, which you might want to check out. And the folks on the call today have been some of our longtime and active members in recent years. I'll hope you guys will let yourself be known as EcoBuilding Guild members. And anyone else who's interested in joining the Northwest EcoBuilding Guild could do that at www.ecobuilding.org. It's quite simple and straightforward. So, all right, next. So we have 2 speakers today, Pat Rasmussen and Mattie Mead. I'm going to introduce Pat real quick because she's got a few perspectives to share at the very beginning. Pat is a friend of mine for the last 35 years. We worked together as forest activists, environmental activists, and in the last 12 years, we've been working very closely on a lot of green building activities, including Pat's efforts to spread permaculture and regenerative agriculture in our community through her group Edible Forest Gardens. And then in the last couple of years, we've been collaborating on her project, Tiny Hemp Homes for Seniors, where she wants to build 11 tiny hemp homes with hemp insulation. And she's also based in Olympia. So Pat, I'm going to stop the share and make you our profile speaker. Let me just find you real quick here. You can start anytime you want. You got your video on? I think you're muted. Oh, I probably need to do that. Hold on. Unmute. Okay, Pat. Oh.
Okay.
There you go. Say hello.
Okay, here we go. Okay. Regenerative agriculture, I'm very interested in that, has the potential to reverse climate change, to reduce temperatures to pre-industrial levels in a matter of a few years. We could sequester more than 100% of current annual CO2 emissions with a switch to widely available and inexpensive regenerative farming practices. The hemp plant is part of that. It pulls carbon from the atmosphere through photosynthesis to make sugars that it sends down to the root zone in the soil. Half of that sugar is shared with microbes in the root zone that then sequester carbon in the soil. Plus, 1 ton of harvested hemp fiber sequesters 1.62 tons of CO2 when the hemp crop is harvested after only 120 days. Now that growing hemp was legalized in the December 2018 Farm Bill, farmers are growing hemp again, hemp that can be used in the building industry. Farmers make over $200 more per acre growing hemp than other crops like wheat. Farmers in eastern Washington make so little on their wheat now, they are considering growing hemp instead. Farmers need contracts to grow the kind of hemp that works for building. Building contractors need a guaranteed source of hemp. Companies like Hempitecture and others mentioned in this webinar make these contracts with farmers to provide a stable source of hemp building materials for contractors. In 2015, when Washington State legalized growing hemp, I decided to build a hemp-insulated tiny home for me. I'm a senior, plus for 10 other seniors. But that's 5 years ago. The hemp building materials have only just now come available. Now I can build my tiny home using hemp board with the hemp wool insulation Mattie will share in this webinar.
Great, thank you, Pat. Now on to the main event. Mattie Mead is here from Hempitecture. Hempitecture has offices in Colorado and Sun Valley, Idaho, I believe. And Mattie has been involved with this hemp building materials movement for many years. Really an active voice in his own community, building hemp buildings in Bellingham and other communities. And he's also the youngest member of the Planning Commission in the Zoning Committee from Ketchum, Idaho.
Thanks everyone for being here today. Really do appreciate it. Want to thank the Northwest EcoBuilders Guild for putting this together. Pat, Rasmussen, Chris. I actually learned about the EcoBuilders Guild while I was working on a hempcrete project in Bellingham, Washington. And while I was spending time in the beautiful Pacific Northwest area, became just aware of the work that they were doing and actually participated in an event that they have, the SLAM Summit, which was an awesome event. So definitely encourage you, if you're unfamiliar with the EcoBuilders Guild, to get familiar and consider being a member. Awesome organization, and thanks everyone for being here. I'm going to dive into a little bit more of an introduction to my background in the pre-recorded webinar. But please, record your questions. This is going to be a very interactive presentation where we'll have some Q&A sessions, and looking forward to hearing what everyone has to say and what everyone thinks, and hope this is an educational and informative session for everyone.
Great, Mattie. Thank you for being here. Maybe you could tell us about some of the upcoming events that you guys have going on before we get into the meat of it.
Yeah, absolutely. So, of course, with the whole COVID situation, a lot of things were on hold, but we're excited to announce that we're starting to resume some of our programming, and it's programming that we find really important. This programming is our contractor training series. So for this contractor training series, we have people come out from all over the United States to our location in Sun Valley, Idaho, and we spend 4 days, hands-on, nuts and bolts, really diving into the basics and the background of building with hempcrete, as well as utilizing hemp wool, two of the materials that we're going to talk about today in this webinar, and that I'll be answering questions on. So we're excited to resume that June 4th. We're keeping our class sizes very small, keeping precautions in place. But following that, we're looking forward to the virtual Hemp Building Summit. Last year, we held a summit in Ketchum, Idaho, where we had almost 300 people come from literally across the world to this little mountain community out here to see hemp building projects in the flesh. We toured a number of projects, as well as we had some incredible speakers from across the world come out and share their knowledge on hemp building. And it's our hope that with events like this, we shine more of a spotlight on natural building using plant-based materials and how we can build more sustainably. So again, because of the coronavirus situation, we're not going to be hosting that in person this year. We're going to have a virtual event. which we're going to announce more details on soon. And then lastly, I just want to thank the Green Home Institute, who we initially recorded this webinar with. They gave us the rights to reproduce this so we could get the message out there. And so big shout out to them for allowing us to use this for this webinar. And so with that, we're going to dive into part one here. And again, as we get going, please record your questions. And Chris, let's take it away with part one. And as we're transitioning here, I do also want to thank everyone for their patience, because this is new for just about everyone. And I'm sure we're all spending more time on Zoom than we ever thought might have been possible. So just bear with us as we get the video queued up.
For structural ingenuity. So go check them out over at tstud.com. And thanks to our second tier sponsor, Niagara Conservation. They make vacuum assisted toilets that we know that work down to 0.8 gallons per flush. And now they have dual flush toilets that work down to 0.5 as well. We have glowing reviews from affordable housing, multifamily specialists who only use these due to their durability, no extra maintenance, and significant reduction in water bills as water bills are going up across the country. You can also check out their 1.25 gallons per minute shower head and their 0.5 gallon per minute aerator. All of these are WaterSense certified. Go to Niagara.com. All right, well, I'm excited to introduce our speaker here today, and I'm thankful because he helped took over here last minute for his colleague who couldn't make it. So I'm very appreciative of Mattie Mead. He is the founder and CEO of Hempitecture. While as an undergraduate studying architecture, Mattie connected with a passion for sustainable building methods and materials. To date, his work with Hempitecture has focused on building healthy habitats that are good for the environment and people that live in them. He currently lives in Sun Valley, Idaho, where he enjoys spending time in the mountains and connecting with the outdoors. So with that, Mattie, I will hand it over to you. Please take it away.
Hey, it's so great to be here today. I'm just going to pull up my screen so everyone can see my presentation here. Thank you for that awesome introduction, Brett. And yeah, really exciting to be here. A little bit last minute for me. A colleague of mine was not able to make it, but I am more than thrilled to share with everyone what we are doing over at Hempitecture and the importance of sustainable plant-based building materials. So just to elaborate on Brett's introduction here a little bit, let's put a name to the face. My name is Mattie Mead. I am the founder and CEO of Hempitecture. We are a public benefit corporation, and outside of my work, of course, I'm passionate about architecture, sustainability, but also being outside. I live in Sun Valley, Idaho, which is a ski resort town nestled in the mountains of Idaho, and living in a beautiful place like this where I get to ski and be outside has further underscored the importance for me and our business to protect our environment and to make building materials that are healthy and help build a better world. So we're going to cover a lot of ground today. We're going to talk about who we are, what was our path, give an overview of hempcrete. Where are we now with these sustainable building methods and products, and where are we going? There's a lot of challenges and opportunities associated with this path, and through my some years of experience in this industry, I am well versed in those challenges. And then we're going to share our new product, hemp wool, which we'll call Hemp Wool 101. So as we start this presentation, I very much so encourage you to think about what we're talking about as sort of all-encompassing in terms of a sustainable building product and method, but we have essentially two lines of products that we're going to be talking about kind of differently here. So in general, what we do is we specialize in what we believe are the most sustainable building materials on the planet. As I mentioned before, we're a for-profit public benefit corporation. We truly believe that the materials and work that we do benefits both people and planet. So we've vested that mission with this structure. Of course, everyone in the architecture and construction industry knows about the problems with our built environment. And in general, those problems are, our built environment is toxic. Our assemblies tend to trap VOCs, trap moisture, create issues of mold, and unhealthy sick home syndrome is becoming more and more common. Of course, buildings also consume 40% of our energy, and that's approximate, as well as buildings are responsible for about 40% of our carbon footprint. These are some big issues, and these are the issues that we work to confront at Hempitecture by using plant-based building materials. So our solution is using building materials that are non-toxic, that absorb carbon dioxide, and lend to energy efficiency. Our materials lend to energy efficiency because they are highly insulating. Most of what we're talking about today should be considered an insulation method or product. We have a bit of a secret weapon in our arsenal here, and most people, this is where they say, what? Or, they start to doubt what you might be talking about. But our secret weapon here is we use industrial hemp biomass for our products. Industrial hemp is very newly legalized in the United States. Just December 20th, 2018, the federal farm bill legalized industrial hemp in the United States. It had been illegal since 1937 to cultivate industrial hemp, and we were the only industrialized nation on the planet to ban the production of industrial hemp. Our neighbors to the north in Canada have never had that we're going to talk about is hempcrete insulation. So hempcrete is very much so a system. It is not just a one-to-one product substitution. It is a method and means of constructing a home. When we're working with hempcrete, it is very different from a conventional sort of cladded style of construction. And just like you wouldn't, frame out a house and then decide, I'm going to put straw bale in my house. You start out day one saying, I'm going to build a straw bale house. That's how I'd encourage you to think about hempcrete. It is a system that has to be considered from the earliest planning stages of your project. It's relatively open source. So what that means is there aren't particular patents protecting hempcrete. Anyone can essentially batch and produce hempcrete. There are some elements of it that could be proprietary, such as the binder, and we're going to go into that a little bit further here. But essentially, hempcrete is a carbon-cured insulation product. There is a bit of chemistry that we'll go over, the building method that's out there, but they also are financially able. With sort of the newness of this material in the United States, there is a cost associated with this. Most of the material itself has to be imported from other parts of the world, going back to sort of our cultural climate of hemp being just legalized here in the United States. So what is hempcrete? It's an insulating, breathable, and fireproof biocomposite. I want to underscore fireproof there, and we're going to show data that's very new to back that claim up, but it is indeed a fireproof biocomposite. When I say a biocomposite, I mean two or more things that are natural that are combined together. So when we combine hemp plus lime and water, we get carbon dioxide sequestration. The essence of that is because our binder, limestone, is essentially calcium carbonate. Now, without getting into too many details here, there are some sort of variations of different binders, but generally we're talking about a hydrated, high calcium lime binder. And when it is mixed with water, it seeks carbon dioxide during its solidification process. So while it's solidifying for up to 3 months, it's actually sequestering carbon dioxide from the atmosphere. But that carbon storage that's happening during the solidification of the composite itself is actually only 10% of the overall carbon dioxide sequestration. And so why hemp? Beyond that 10%, the biomass from rapidly renewable industrial hemp offsets about 9.8 tons of CO2 per acre. This graphic is actually from the Rodale Institute, an organization out of Pennsylvania. They're a nonprofit organization working to promote regenerative agriculture and carbon farming. And this statistic is also from the Rodale Institute. So 90% of the carbon storage of the end product itself comes from just the mere cultivation of industrial hemp. We could certainly get in a wormhole about carbon offsets, carbon sequestration. Could go all the way back to how much fuel did the farmer use in his tractor. But the point being that we make is that hempcrete is a carbon storing building material. And, you know, there's a reason that this all matters. And this is a chart that is now actually a little bit outdated, but I keep this in here because I got involved in this industry when I was a student studying architecture. And I was really enamored with the mission of Architecture 2030, another nonprofit organization working to decarbonize the built environment. When I learned that buildings and their operation are responsible for about 40% of our energy consumption and carbon footprint, it became my calling. My senior year of college, where you can see a much younger, less bearded version of myself pitching for sustainable building materials. I was presenting across the United States this concept of building with biocomposite building materials. Now, of course, at the time, industrial hemp was legal. Many people joked, oh, you're trying to build houses using something that's a Schedule I substance. But we very firmly believed that, you know, within a reasonable amount of time, industrial hemp would be legal. And we should take note of the examples from around the world, particularly France, UK, Belgium, the Netherlands, and so on and so forth, who are already using these highly sustainable building methods. When I was pitching that concept, it was all about a product concept, a building block that was essentially interlocking, kind of stackable like Legos that could be poured with reinforced concrete to make a thermally efficient envelope that was also structural at the same time. But of course, concepts have to be funded to be real. I did not receive funding for this, but it didn't discourage me because I had an opportunity after college to really start to work with hemp building materials and get some hands-on experience. So I graduated from architecture school and I had the opportunity to move to Idaho. As someone who grew up in the Northeast, if you had asked me 10 years ago if I'd live in Idaho, I probably would have said, I don't know where Idaho is. But I went out to Idaho for the first time to meet with an architect and work on this design build project for a nonprofit organization. This nonprofit organization said, hey, use our property as a laboratory for natural building. We want to show off different methods of sustainability. And the reason that I bring this up is because that is where hempcrete was at 5 years ago, and for the most part still is. It is relatively niche. It is, you know, forward-thinking organizations or clients who are, you know, eager to do something different, but by no means has it, you know, swept our construction market. Also, being a nonprofit organization, we had to fundraise for this project, and we actually raised money on Kickstarter. We funded the building materials, which actually were imported primarily from Canada to Idaho for this project, basically just based off of a sketch. We worked through a sort of design process. I worked in the architecture studio every day with the architect who was sort of my mentor. And I'm sure some of the architects can relate out there. You know, as a design build program, I was in there doing the drawings myself. And then I was out in the field with those drawings wondering, okay, how the heck am I going to put together what I just drew? Being that we were located in the high altitude region of Idaho at about 7,000 feet above sea level, we have pretty quick turnover for seasons here. Hempcrete, being a biocomposite material that is mixed with water, it has to dry out, and freezing temperatures are sort of a negative for the curing process of hempcrete. This project, because of a necessity, was done with sort of an innovative building method. And I just want to kind of keep in mind that as we go through these projects, each one is going to be indicative of a different kind of building method, so that perhaps you could, at home or at your office or your firm, think about the different ways that hempcrete could be implemented. So this project, to keep the timeline quick, steady, was done with a panelized building method. We essentially prefabricated these panels on site, installed the hempcrete in them, stood them vertically, allowed them to cure while the work was happening on site. We had, you know, the concrete foundation already being put in place. allowing us to skip that sort of 3-month curing time, which certainly is a limitation and challenge when working with hempcrete, to ultimately having our envelope that would be encapsulated with a post and beam frame erected by wintertime. Not to mention, this property was located over a mountain pass road that's only open probably about 7 or 8 months of the year. So getting all this material there, having everything built and done in time for winter was absolutely imperative. Through this learning experience, this project ultimately became a community building for this nonprofit organization that was opened in 2016. This building project for me put into perspective really the challenges of working with hempcrete, let alone being sort of in a rural job site, but the challenges of working with hempcrete, getting the materials to your project site. How does the material integrate with a structural frame overall? And then what are the finishes for hempcrete? With it being a vapor open breathable wall system, how do we finish that out effectively? The project itself was a tremendous learning experience for me. And following that, I realized if I'm going to apply this sort of niche new building material to conventional building, I have to learn how to actually build buildings. While I thought my architecture program equipped me for that, and to a great extent, my architecture program really, expanded what my sense of design and architecture is, it didn't teach me hammer and nail. So learning hammer and nail, working with a construction firm in Sun Valley, I soon thereafter had the opportunity to work on a different project.
Thanks for watching. Please continue to watch the next part of the session to complete the course and get your continuing education credits. Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEU.
Now, this project called the Highland Hemp House was in Bellingham, Washington. A totally different style of construction from the Idaho Base Camp project, sort of conventionally framed, but it was also an addition, renovation, and a retrofit. So this project, again, sort of opened up a new element of how hempcrete could be used. And what was considered is how does hempcrete integrate with a frame that's pre-existing? How do you annex off of that frame with conventional framing? But also, how do you frame for a hempcrete building that is of this size? Using my sort of experience gathered from working in conventional construction, I was actually hired as the sort of framing foreman with locally hired labor to build this house in Bellingham, Washington. And I think that's important to point out because going back to that sort of metaphor of you're not going to frame out a house conventionally and decide to put straw bale in it. You decide from day one you're going to build a straw bale house. The envelope for hempcrete has to be considered. The framing has to work with hempcrete. And so I got myself into a bit of a mess here. I moved out to Bellingham to work on this project. We did have absolutely outrageous fees, which only increased as the project went on. But realizing all the layers of the onion of this original house, it was tough to work through this and build from the foundation up. But I think considering hempcrete from the foundation up is absolutely imperative. So on day 10, I think I spent my first week sort of chiseling out bedrock from the basement, looking to put in new sonotube foundations and footers to support the new loads above. It was a tough job, but making some progress on the framing. All of this framing was done to consider the incorporation of hempcrete around it. You're going to notice that there is not any shear panel on the exterior of this building. Where you will see shear panel, OSB, is generally on the inside. If you look sort of on the first story there, you can see some interior shear walls. That's because hempcrete wall assemblies are vapor open. They need to be able to pass vapor through them. OSB and plywood generally interfere with that process. So shear walls in your structural engineering of a hempcrete building are also a challenge in their own right. You'll also notice that there's some diagonal bracing going on that's mounted onto just sort of the outside of the framing. Day 100, figuring out how to build a curved fascia was quite an exciting challenge. But you'll notice that, we have some sort of open voids here, and I call out attentions to the corners on the second story above the there's a door opening that would lead out to a deck. There's posts on either side of that door. Well, how do you get shear value for a hempcrete building without having plywood or structural substrate on the outside? The answer generally is X braces. So we had some zones that were left open for essentially a sort of hybridized commercial style X bracing system using gusset plates, steel X braces that were essentially prefabricated in a shop and then installed on site, gave our corners the rigidity that was needed. While we're still on this framing photo, another thing that I just want to point out is that hempcrete is usually cast with depth. You're very rarely, if never, building a hempcrete wall that's just matching the depth of your stud. So you wouldn't have a 2x4 or 2x6 depth of hempcrete for a few reasons, one of which is the thermal performance most likely wouldn't be sufficient. But the beauty of hempcrete is that it can eliminate all of your thermal bridging. So this entire house was framed out with the idea of a frame on center, meaning we had essentially an 11.5-inch wall. So our bottom plates were 11.5 inches. Our studs were laid out on center, and where we had 2x4 studs, that left about 3 7/8 inches on either side of the stud to the finished or to the unfinished surface of hempcrete before plaster. So all that has to be even factored into your overhangs. If you want your overhangs to be a certain distance, you have to consider, hey, my finished material is going to come out 4 inches, 4 3/4 inches past where my structural frame is. But in building this house and becoming intimately aware of sort of the nuances and challenges that it would take to incorporate hempcrete on this, we started to look at the project with sort of a systems thinking approach. In general, systems thinking is a disciplined approach for examining problems more completely and accurately before acting. And so what that meant to us is, hey, we have thousands of pounds of material that has to get mixed and batched on site. It has to get brought to the wall itself. It has to get placed in these wall forms and then tamped down into place. How do we do that, on a 3-story building efficiently and effectively? And so this systems thinking approach caused us to kind of take some time and actually plan out the hempcrete installation, which I cannot emphasize enough the critical elements of planning a hempcrete construction process, because once you start, you really want to keep going. It's kind of like concrete in the sense of once you start pouring concrete, you don't want to just stop in the middle of it and come back later and finish the rest. So we use technology to our advantage. We had a series of mixers that were working together. We had remote controlled operated winches that were bringing this material up to our higher stories. And we're also using conveyor belts, systems that would allow us to distribute this material, which looks very much so like wet wood chips when it's first mixed, into the wall cavity. The really labor-intensive elements of hempcrete ultimately come from the mixing process, the forming process, but then The last quadrant there on the looker's bottom right is tamping the material into place. All material has to be tamped into place to give it this sort of stamped aesthetic that you can see here. Hempcrete is brought up to the rafters, touching the subfloor above, creating continuous insulation. We use conveyor belts to move this material around to get it inside, but now you can see the structural frame is essentially vanished. That's because it is on center to our wall, meaning we have no thermal bridging in this assembly. There you see one of our team members removing a form board on our 2-story curved wall. And you can see we are relatively spread out across this house installing the hempcrete in it. It certainly has a beautiful aesthetic, almost kind of like rammed earth. Ultimately, the end product for this project looked like this. You can actually see I should actually clarify, the end product for our scope of work, the hempcrete installation, looked like this. You can actually, if you note, see the stratification of the hempcrete itself. In particular, that 2-story curved wall is a southern facing aspect, kind of causing the surface to dry out a little bit more quickly, which ultimately doesn't affect the material as a whole, but it does sort of bring out that stratification of the material. Every single course of this product in this style of construction with hemp is tamped into place. And we would call this method cast in place. It's sort of an artisanal, high-end, high-quality approach that is indeed very labor-intensive, however, kind of results in what I would say is the highest quality outcome for hempcrete. Quickly, I'll just call attention to the door on the 2nd-story deck. You can really get a sense of that hempcrete encapsulating the frame, with that frame being buried on center. I'm sure the architects out there are thinking about the detailing that is invoked when you have an inset door or window frame, and certainly with this construction method, there are some considerations to be had when you are flashing, waterproofing, installing windows and doors that are on center to a wall system like this. Ultimately, the house has a number of solar panels, and they are producing more energy than they use today. So the Highland Hemp House, by the numbers, it was a labor-intensive process. About 1,500 hours, man-hours, went into this project. When we say hemp aggregate, we're referring to hemp core, which goes back to that idea of you're combining the wooden core of the hemp stalk, which is very processed for this use. You're combining it with a lime-based binder, in this case, primarily hydrated lime and a pozzolan. 12,000 pounds of hemp aggregate, 23,000 pounds of lime binder. And ultimately, this offset, we estimate to be about 15,372 pounds of carbon dioxide. That does not consider, the sort of on-site considerations. For instance, our mixer is gas-powered. We were using electricity constantly to power our tools, charge our batteries. This statistic solely relates to the generalized statistic that 1 cubic foot of hempcrete offsets about 7 pounds of carbon dioxide. So this was a really exciting project, kind of a showcase project, and there have not been other building projects of this magnitude really conducted in the United States. So kind of challenge us to think about, what's possible with this material. But aside from cast in place, there are other methods of installing hempcrete. Just this past summer, we partnered with a French inventor who created a spray applied projection system that allows the spray application of hempcrete into a wall cavity. So to put this into perspective, the cast in place method of installing hempcrete, you're looking at about 10 to 15 cubic feet of material installed per hour. Whereas with this spray applied method, you're looking at about 50 to 60 cubic feet installed per hour. By no means is it perfect. It's certainly a faster, potentially messier means of installing hempcrete, but still a bit of a leap forward from this idea of hempcrete only being reserved for, the people that are that 1% I alluded to for the overlapping diagram of sustainably motivated yet financially able. Ultimately, using this spray machine and system would lower your costs. You'll lower your on-site time, but your wall assembly is going to be a little bit different. You can see in this method, we are actually spraying against a substrate. That substrate is a material that is called magnesium oxide board. Magnesium oxide board is essentially compressed magnesium. And the reason that we're using magnesium oxide board in this method is because magnesium oxide board is vapor permeable. It allows moisture to pass through it without any degradation to the material itself. At the same time, it's serving as our shear panel and ultimately our interior substrate for finish. So with the spray system, you have to have, and this actually goes for really any type of hemp building process that's using hempcrete, your conduit, your wiring, everything has to be encapsulated in what we call Smurf tube, which is indicated there in the blue tubing. So it has to be run through that. So if you ever want to make changes later on, you have essentially a highway to snake your material or wiring through. Moving on from the spray applied projection system, which one last note on the spray applied projection system, I would certainly recommend sort of a double stud construction for this style. You never see spray foam that looks pretty. And it's not that this method doesn't look pretty, it's just that it's a little bit more challenging to finish out. So you could sort of blow and go on a double stud wall assembly, have your hempcrete hidden, and it doesn't matter the finished surface or how it looks. Moving on to just a kind of quick demo construction project that we did. We built a panelized tiny house, and we wanted to experiment with the idea of prefabricated elements that would be constructed in one location and then ultimately to another location. By casting these panels flat with a mixer nearby, we were able to just essentially dump the hempcrete right into the panels without having to fight gravity. We allowed the panels to dry, and then we brought them to a very remote and rural site where we essentially raised these panels. We could not get a crane here, but of course, if this were done on a larger scale, you could essentially strap these panels up or have them on a forklift and set them on a foundation quickly and easily. You'll notice that the exterior of this small build is also magnesium oxide board, which I think is worth pointing out is fireproof. So we're cladding a fireproof material, hempcrete, with a fireproof cladding, magnesium oxide board. This ended up being particularly valuable because during the construction process of this house, and I'm very proud to say I was not the originator of this brush fire, but a neighbor nearby started a brush fire that scorched all of the sagebrush surrounding the home. And we were very pleased because the house itself, although it has a timber roof, would be not susceptible to the fires, which seem to be a sort of growing concern in this area.
Thanks for watching. Please continue to watch the next part of the session to complete the course and get your continuing education.
in terms of like where we are and what's holding us back, there's a bit of a lack of codes. We don't have standardized codes or anything to bring to a building inspector in a certain jurisdiction and say, this is what we're doing. This is, these are the standards that it meets. However, there are these sort of standards in other countries, but we're lacking a big one, ICC. It is our hope that at some point, you know, we'll be able to move towards this, and there'll be legislation, there'll be, you know, codes, regulations, things that will allow us to more easily adopt this material. In the center there, you see a pretty sophisticated looking piece of machinery. That machinery is what we call a decortication system. To get the hemp that we use, we're not just going out into the field and cutting down stalks and throwing them into a building. This is a highly processed, highly refined constituent of the industrial hemp stalk called the core. It has to be removed of the long fibers, and this has a bit of an investment cost up front. In Canada, they have these systems. In the UK and Europe, they have these systems. However, in the United States, with our sort of new legislation, the investment cost, as well as sort of the startup inertia to get a hemp processing facility going is pretty high. There's a barrier to entry there. So we are hoping to see more of this come online, particularly in the United States, so farmers can cultivate this commodity here, and they can be converted into high value materials that not are only for just building materials, but automotive panels, textiles. There's companies that are now making lumber out of the pressed hemp core. Company called Hempwood is making flooring. So there's a lot of potential here, but there's just some things holding us back. To confront that issue, we have been able to do some testing. This is perhaps the most unexciting graph that has ever been produced, unless you are us, which shows a 0 across the board. You can see that the bottom axis there is flame spread distance versus time. There's no flame spread for hempcrete. This test was done just recently with a testing laboratory based out of Texas. On a scale of 0 to 450, our smoke spread index was 0, and our smoke developed index was 0. So now, for the first time ever, hempcrete is certifiably fireproof in the United States, whereas in other parts of the world, they've known this. You know, we've shared documentation from France with building inspectors, and they say, oh no, this is from France, and it's in metric, and you know, the laws of physics are different in France than they are here. So we finally have this test done in the United States, which we really hope people will be able to use this documentation to advance their projects here in the US. So that's kind of the conclusion of hempcrete. There's so much more to be done in terms of testing, researching, and developing more efficient, cost-effective methods of implementing hempcrete. I truly view hempcrete as the pinnacle of sustainability in our built environment, but I've realized it is not for everyone. There's a bit of a barrier to entry there. And so we have a more entry-level product that has some of the benefits of hempcrete, but it's a one-to-one replacement. Going back to that idea of, you're not just going to swap out hempcrete for your fiberglass. That's where hemp wool comes in. Substitute your fiberglass, take out your spray foam, get rid of the VOC containing toxic insulation materials that are prone to mold, have huge embodied energies, carbon footprints associated with them, and replace them with a product that is 92% plant fiber. It's high performing at R3.7 per inch. So we have a few different versions of this product. One is a 2x4 version, which amounts to about an R13. And then we have an R20 product, which amounts to, that's our 2x6 depth. So it's a pressure fit system designed to just fit in your studs. Very little modification is needed for the panels. And we view this as something that's truly scalable. At Hempitecture, our mission is to very much so benefit our world, people, planet, by incorporating sustainable materials into our built environment. But we know that there's not going to be a great environmental benefit if only a couple people access the material, if only a couple of projects per year are built using hempcrete. So we see this as a scalable means of incorporating health and sustainability into your home. Quickly, just kind of touching on the benefits here. It's a sustainable product. It's bio-based. There's a low carbon footprint. Remember that statistic about industrial hemp, 90% of the sequestration occurs during the cultivation of the crop itself. It's got great performance. It's got an R value of 3.7. It's able to store heat, which is a very unique quality of this building product. It's efficient to use. It's easy to install. It's non-toxic, and at the same time, it allows your house to afford some soundproofing. And the number one question that we get asked is, are critters and insects going to like this? The answer is no, because of the other 8% of the product, which is essentially a binder. It's a recycled textile, the material, and it'll hold that, allowing you to just cut a line across it. So quickly, I'm just going to show a couple of videos here, one of which covers the installation method for hemp wool, and then the other is going to just kind of dive a little bit more into the tools of the trade. So this is from a project in California that we recently just completed. Hey guys, I'm Mattie Mead, founder and CEO of Hempitecture, and today we are on site in Los Angeles, California, working with our new product, hemp wool. Hemp wool is a high-performing fiber bat insulation product. It's made from 92% industrial hemp. It can be cut and placed into your stud bays to insulate your thermal envelope, as well as insulate from sound. So over here, I'm going to show you the basic technique of installing Hempitecture hemp wool. We've already got this one pre-cut. What we're going to do is, whatever size the stud bay measures, we're always adding a 1/2 inch. Hemp wool is a pressure fit insulation system. You lean it up, press it in, smooth out the sides. So I'm going to show you the basic technique. Always start at the bottom so you're not leaving any gaps. You really want to get one side to where you like it. And then you can take your other hand while holding and supporting the panel and kind of pop it in to the stud bay. Once that's popped in, you can see that it's protruding past the framing plane. You want to be able to smooth that out. And the best way to do that is just take your hands and rub them down the side of the panel. And just like that, you've got hemp wool installed. We're going to put in this top piece to finish it. Just as we were adding a 1/2 inch with the stud width, we're also adding a 1/2 inch from the top of the panel to your block. So it's a pressure fit, snug system. Sometimes you have wiring and plumbing in the walls. With hemp wool, you have to notch around that. So on the back of this one, you can see we've already notched for this wire that would typically, if we just put this hemp wool over it, it would hold it out, make it bowed out, and that would ultimately affect the drywall or whatever finish you're going to put on. So we have this notch here, line it up, place that in, smooth it out, and you're on your way to having a healthy, comfortable, non-toxic, high-performing home. Hopefully there wasn't too much lag there on that video. If it did not play super well, we can also see that on our YouTube channel. Hopefully that was clear. But we're going to move on to just the next slide here, which for the data nerds out there, the ASTM standards are really important. Hemp wool has ASTM standards associated with it. It's been tested, it's been proven. And so I just wanted to put this up there so people could maybe take a screenshot of it or reference it. But just know that we do have this information and data on the product. Lastly, of course, hemp wool is not a fireproof material like hempcrete, but it does meet, general ASTM requirements for flame spread. And so with that, I'm going to conclude the presentation.
I'm sure people have some questions. So if you have a question for Mattie, go ahead
and unmute yourself and ask your question, and then Mattie or Pat will respond. You can also raise your hand if you'd like, and I'll call on you. Anyone want to raise your hand?
Hello.
Yeah, go ahead.
I have a question. Hi, everyone. It's Corina. I have a question. I just added it in the chat. So this is regarding the hemp wool assembly, and I was wondering if I were to use hemp wool and the magnesium oxide boards and then a lime plaster on the inside, would that result in a similar kind of breathability and kind of hygrometric performance of the wall as if I used hempcrete?
Hey, Karina, that was a great question. Thank you. So yes, magnesium oxide board is vapor permeable. Hemp wool as well is vapor permeable. And so those materials in conjunction would lend to a vapor permeable wall system. The finish, however, on that, which would be a lime-based plaster, or would have to be a lime-based plaster or say a clay to maintain that breathability. There's different ways that you can use magnesium oxide board, whether it's on the exterior of your house, used as a sort of a shear panel, or on the interior, used as sort of your drywall finishing. You are able to plaster directly onto the material itself. However, it may require a multiple coat system to properly and evenly coat the magnesium oxide board. So it's a pretty versatile material. You can use it in a few ways. Of course, there are downsides to other materials that are out there. For instance, magnesium is not readily available here in the United States, and so magnesium oxide board is generally imported. For us, it works great as a means to cast hempcrete against. You could cut down on the labor intensity of a hempcrete wall by siding one side of your wall with a permanent MGO board shuttering, and still allow the hempcrete to cure. In terms of it being identically to hempcrete, it would have a lot of its attributes, but it's going to lack sort of the thermal mass that hempcrete would have. Hempcrete's always cast in depth, and you very likely, if following a conventional construction program, are still going to have thermal bridging by placing insulation solely between your studs, as opposed to hempcrete minimizing that thermal bridging. So vapor permeability, yes, will remain, but there are some benefits there to incorporating hempcrete rather.
All right, anyone else want to raise a question?
Yeah, I got a question. It's Gordon from Detroit. Can't tell if you can hear me or not.
Yeah,
Thumbs up.
Hear you.
I'm planning on using shipping containers. I understand that they aren't, it's not a permeable wall construction that I'm going to be insulating. I'm mainly interested in the insulation factor of hempcrete as an exterior siding and the insulator. So my question really is about, is it better to use brick hempcrete to build that wall, or spray on? And does the curing factor cause a problem with the shipping container?
Hey, Gordon, thanks for your question, and also thanks for your support over the years. I always see your name popping up on our Facebook, so I appreciate that. You could use hempcrete in conjunction with a shipping container. However, there are some challenges with that. So a first challenge might be that a shipping container itself is metal. It may not be galvanized. And so with that, you need to protect the material itself from the lime, which is corrosive to metal. Because it is a non-vapor permeable material, that is the metal container itself, you would lose really one of the more important benefits of why you choose a hempcrete wall assembly, and that is its breathability. So I would think that, with it being cast against wet hempcrete being cast against a shipping container, it might create some challenges for a slower curing process, Do I think it's impossible? No. But I think also, the pre-cured route of blocks would minimize all of those challenges that you would have up front with casting or spray applying wet hempcrete against it. I definitely love the idea of modularity and using shipping containers, things that are essentially just abandoned or have no end life as solutions for housing. And so I certainly see definitely a lot of application there. But in terms of hempcrete integrating with that, it is kind of a tricky subject. You would also, as you had mentioned, most likely want to cast it, or apply it on the outside, because shipping containers are not very large, and the density that would be required, or I should say rather the depth that would be required for hempcrete ultimately would really take up a lot of the interior space.
Yeah, and I got all kinds of room on the outside of the building. And I could sequester a lot of carbon. So where I'm planning on building here in Detroit and in Northern California in the high desert, we have 100-degree temperature swings. And so if I can minimize the temperature difference inside the shipping container, then my heat and electricity bill goes away, provided that the hempcrete process is cheap enough to do en masse.
Yeah, and you're getting an important point there, that there is a bit of a cost associated, with hempcrete upfront. That to actually do a return on investment calculation, you kind of need to figure your costs up front for the hempcrete. But I do think it's possible. I have never personally worked with shipping containers, so I can't speak to it from a place of personal experience. But
would you like one?
Can I ask a question, Gordon? Are you, just so I understand, are you thinking of putting the hempcrete inside the container or pack it on the outside? Which makes
completely on the outside.
Outside, right?
Yeah. Yeah, my concept is to use 3 shipping containers in a U shape, and then a glass greenhouse in the middle of the U, and then wrap the exterior of the shipping containers with hempcrete as a blanket, and solar on the roof, on the metal roof, but then basically build a earth ship, but use shipping containers and hempcrete as the mass insulator.
That's awesome. Yeah, and that, I mean, then you don't lose any space on the inside, and I think the drying will also be better, right? Because it dries. Then it might actually dry too fast in the desert climate. Because I have a project in the desert also here in Southern California, and I'm looking at hempcrete for that. But this one doesn't have.
So that's why the brick idea looks very appealing, because then you can control all the processes in a warehouse, and then just bring the bricks on site and assemble.
Do you plan on backfilling to the hempcrete?
Well, that's the concern about, how much of a do I need a vapor barrier? Do I need, is there a void because of the texture of the shipping container is variant? Do I use that as air pocket? There's a lot of variables, but if I'm using a foot thick stone made out of hempcrete that's Lincoln log or Legos essentially, then I'm just building a retaining wall, nothing more, and it's my insulator.
Yeah, Gordon, thank you for your question, and I'm happy to kind of talk about some project details and specifics of what you're looking at a little bit more offline. And while we still have some participants in the group, just want to get to some of these other questions as well. But yeah, happy to continue the conversation, Gordon. I did see a question just before from Leland Johns regarding decortication as a roadblock. And so just to touch on that, decortication, and there are companies in the United States working on processing and decortication. There have been some ventures already. There's new equipment, new technologies that are coming out as we speak, as well as sort of time-tested technologies and strategies that are used in European countries. But the issue of decortication is kind of one cog in an ultimate supply chain issue. And so for there to be decortication, There needs to be farmers who are growing the biomass and the technology in the fields to harvest that biomass, successfully bale it, bring it to the decortication. But then once it's decorticated, there needs to be buyers. There needs to be people who are looking to use this material in commercial or industrial applications, because it's going to produce such a large volume that we need to buy it, or else it's just going to be processed and then going really nowhere. And so it's our hope that we can really utilize a lot of biomass via our projects by way of the processed hemp hurd, or hemp core as we call it, because we call it hemp core because it provides this idea of as the core of the stalk. And that's what we're after when we're talking about hempcrete. It is a cleaned, processed hemp core that generally is broken down into a uniform length, separated of its various constituents, and then made as an aggregate for hempcrete. So I mentioned in my presentation before that there is a large across in decortication. There certainly is, and I think that it's fair to understand and expect that with industrial hemp just being legalized over the 2018 Farm Bill session, that this investment and this market is building up. I think initially there was a lot of interest in industrial hemp relating to CBD. I think we're seeing that market start to peak a little bit, and people are going to be interested and curious as to some of the other types of industrial hemp. And so really what we're after is a fiber variety industrial hemp versus a CBD biomass. But to that point, I think it's an exciting future to imagine, the possibility of taking CBD biomass or other biomass that's not, grown specifically for the purpose of building materials, and still being able to recycle them and use them to kind of create a closed loop system. We're growing plants and we're utilizing the whole plant as opposed to just a small constituent of it. So thanks for that question, Leland.
Hello.
Hey, we can hear you. Who's this?
Hi, my name's Joe. I have a quick question. Can you please explain a little bit more how it works and the effects of hemp wool and hempcrete in soundproofing? You're muted.
Sorry about that. Your question cut off there for me for a second. Your question was about sound attenuation and sound absorption with hemp wool?
Yes, and hempcrete.
Awesome. So speaking from anecdotal experience in regards to hempcrete, I have not personally conducted any sound attenuation tests on hempcrete. I believe there are sound acoustic, sound attenuating properties to hempcrete without a doubt. But speaking of personal experience in the buildings that I worked on, once they're done, it's a magical feeling, almost this feeling of sort of stillness that you get by way of essentially the lack of reverberation. So, in conventional clad structures, there's sort of a pingy, hollow, bouncing sound, and that is the sound bouncing off of these materials that are not really absorbing it. Hempcrete, from my experience, seems to absorb sound really well. And in fact, the first building project we worked on, the Bora Basin building, which is used as a community center for a nonprofit organization, we often have live music in there just because it sounds so great. So that's one of the really awesome benefits of hempcrete. Hemp wool itself is sound attenuating. It can be used for sound absorption. There is a specific line of hemp wool at a 2-inch depth. It's a little bit denser. It's better for sound attenuation. But whenever you clad a material, whenever you cover a material, so in the case of hempcrete, you're covering it with plaster. I'm sure it's still going to retain some of its sound absorption qualities, but that layer will also ultimately reduce the sound attenuation of the hempcrete itself, just as if you're putting drywall over hemp wool, it would also reduce that effect as well, opposed to it being exposed, which you can see in the office here.
Mattie, this is Chris. I wanted to draw your attention to a question that's in the chat box. Tad Everhart from Portland, Oregon asked about whether there are reports available on the R value and other specifications for data test or test data reports that would be used for code submittals and that sort of thing, and where you can get those.
Yeah, that's a really great question, and I think it speaks to sort of where the hempcrete industry is in the United States, at least as a whole. There's definitely a long way that we have to go to get testing and data and documentation. The U.S. Hemp Building Association is now putting together a committee to work on getting some of these permitting issues sorted out, which is a great thing for the industry as a whole. The answer to your question is yes, there is that data. But no, it is not necessarily based from the United States. So you can see a lot of U-value and thermal conductivity testing from Europe. There's a lot of great researchers out there who are working on research surrounding hempcrete and how it performs. A speaker at our Hemp Building Summit last year, Liam Donahue, is doing a lot of research there. And he's already provided the research paper on acoustic absorption. Good looking out, Liam. Thank you. So there's a lot of research that's happening out there. The only testing data that we have compiled relating to hempcrete in the United States is the ASTM E84 test. And ASTM E84, as I mentioned in my presentation, relates to the smoke developed and the flame spread of a material. And so this test was done actually for a client of ours who made it possible because they are building in a rural location with a low flow fire hydrant dilemma. They need to build with a certain type of assembly, and that assembly requires everything to be non-combustible. Just telling the building inspector, oh, hey, hempcrete is fireproof was not satisfactory for the building inspector, which is understandable. And so we conducted this test, which essentially consisted of a number of samples, ultimately adding up to about 24 feet long. And they were run through a burn chamber. So they were thin slabs run through a burn chamber. And as I mentioned and showed the graph, it showed zero smoke developed, zero flame spread. So that's an exciting kind of leap for us here in the United States to at least have some data. And our hope is that other people in the United States will be able to feel the benefits of that test, and we make that freely available. There was a question in the chat not long before, where can we get access to that report? We're happy to share that with anyone and everyone who would like it. And so you can feel free to contact me directly and just say, hey, I'd like to see the ASTM report, and we're happy to send it to you.
Mattie, do you have that on the web where you could just share links to the report on the chat? Oh, Matt, sorry about that.
No problem, thank you. So the question was about hempcrete as a structural material, hempcrete in relation to foundation walls and in ground contact. I'll start there because that's a little bit of an easier answer. As it exists now, hempcrete is not well suited to act as a foundation material because it is non-load bearing. There is some structural capacity to hempcrete, but it is not often used as a load bearing material. That is why in general it is either cast or sprayed around a structural frame, or a block system itself would have some other sort of structural reinforcement, whether it's poured concrete and rebar, or some other means of structure. For instance, the biofiber in Canada has a sort of interlocking peg system that supports the courses of blocks above. But as it exists now, I would not recommend putting hempcrete in contact with ground because the ground contains moisture and will wick moisture and ultimately could compromise the material as a biocomposite that is remaining solid and sound. With that being said, though, I do think that there is a potential feature for structural hempcrete, and I know that there has been a lot of work done on researching what